Welcome to this Blazor DataGrid tutorial. In this video, I will show you how to implement semantic filtering with local embedding in Blazor DataGrid using Syncfusion UI Components, local embedding generation, semantic similarity comparison, and dynamic query construction. Semantic filter enables you to filter data based on meaning rather than matching exact text, and makes your data grid smarter, more intuitive, and user-friendly. Visual Studio is already launched, and the Syncfusion Blazor DataGrid component is set up with the basic configuration in a Blazor web application. I have also bound it to a list of medical records, configured the required columns, and enabled features like alternate row styling and text wrapping for improved readability. To learn how to get started with the Syncfusion Blazor DataGrid component, check out the video linked in the YouTube card or in the description. Before implementing semantic search, I need to install the required NuGet package. I open the NuGet package manager, go to the Browse tab, search for Smart Components Local Embeddings, and install the necessary version in my application. This package enables the generation of local embedding for semantic similarity checks. I navigate to the Imports Razor file and add the following namespaces: Syncfusion Blazor Data for data operations, Syncfusion Blazor Navigations for toolbar components, Syncfusion Blazor Inputs for input components, Syncfusion Blazor Buttons for button components, and Smart Components Local Embeddings for embedding generation. Embeddings convert text into numerical vectors that captures the meaning of the original words. Next, I need to register the required services. I navigate to the Program CS file and add the Smart Components Local Embeddings namespace. Then, I register the local embedder services using add singleton. Next, I will show you how to implement semantic filtering with embedding in Blazor DataGrid. First, I navigate to the Home Razor file. Next, to add a Syncfusion toolbar component with a search box and button, I add the Syncfusion toolbar component inside the Syncfusion grid component. This toolbar will hold the search input and button. Inside this, I define toolbar items, which represent individual items. For this scenario, I add a single toolbar item and set its type property to item type input because it will contain input controls. Next, I use the template tag inside the toolbar item to customize its content. I add Syncfusion text box. This component is used for entering the search text. I set its placeholder property to search here. To bind its value, I create a string variable named search text. Then, I set the bind value property to search text. Next, I add the Syncfusion button component. This triggers the semantic search when clicked. Then, set its content property to required content, and assign the onClick event to the onSearchClicked method, where I'll add the logic for semantic filtering. Then, I add the required CSS styles to ensure proper alignment and spacing for the text box and button. Next, I will convert medical records into vector embeddings for semantic search. To achieve this, I inject the local embedder service, which will help generate embeddings for semantic similarity checks. Next, I initialize a dictionary named Record Embeddings, where the key is an integer and the value is an embedding of 32 object. This dictionary will store the embedded vector data required for semantic search operations. Next, I iterate over each item in the medical records collection using a for-each loop. For each record, I create a single string by combining doctor details, symptoms, and diagnosis. This combined value will later be converted into a vector representation, because semantic search works best when all context and intent are included. Next, I generate the vector data for each medical record by calling the embedder's embed method. This produces the vector representation that captures the semantic meaning of the record. Next, I add each embedding to the Record Embeddings dictionary using triad, storing the record ID as the key, and the embedding vector as the value. Now, Record Embeddings data is ready for downstream semantic search. Let me add the semantic search functionality to the application. First, I set a similarity threshold value to 0.6. This number helps the system decide which records are semantically close enough to the search text. Values above 0.6 are considered semantically similar. Lower values mean weaker similarity. You can adjust this number to make the search stricter or broader. Next, I create a private field named GridQuery, which will store the final query that is applied to the data grid. Then, I create the onSearchClicked method. Inside this method, if a text is entered, the semantic search can be continued. Otherwise, reset the grid query by assigning a new query. When semantic search is required, I first get a reference to the symptoms column from grid instance by calling getColumnByFieldAsync method. This is needed because the grid will filter results based on this column. Next, I embed the search text using the embedder's embed method. This converts the text into a vector that represents its meaning. Then I loop through all the medical records and retain only those where the similarity score between the search text vector and the record's embedding is greater than the threshold value. A higher value means a stronger semantic match. These become the list of filtered records. To show these results in the data grid, I will define the renderQueryForFilteredData method. This method will accept the filtered data and the target column. It will build a Syncfusion query object that applies the necessary filter conditions, instructing the grid on which records to display. I will pass the filtered records in the symptoms column to the renderQueryForFilteredData method from the onSearchClicked function. The method returns a final query, which I store in GridQuery. The data grid uses this query to display only the matching results. Inside the renderQueryForFilteredData method, I declare a local query variable to store the final query used for filtering the grid. Next, I create a list of where filter objects. I loop through each filtered record, extract the symptoms using reflection, and add a new where filter for it. Each filter checks whether the symptoms field contains the extracted value, ignoring case differences, and also the OR condition set. This ensures that even if one symptom text matches the semantic meaning, the record will still appear in the results. After creating all the filters, I combine them using whereFilterOr and return the final query. Then, I set the grid component's query property to this newly created query so that the data grid displays the filtered records. Finally, I run the application. In the output, you can see the data grid component with the semantic search feature enabled. For example, if I type stomach pain and click Smart Search, the grid will show all records related to issues in the stomach even if the word stomach does not appear precisely in the data. Now, let me try a more descriptive query. I type high BP and click Smart Search. The data grid now returns records that are semantically relevant to elevated blood pressure. Now, let me summarize. In this video, I showed you how to implement semantic filtering with embedding in Blazor DataGrid using Syncfusion UI Components, local embedding generation, semantic similarity comparison, and dynamic query construction. For more information on the DataGrid features, check out the documentation link in the description below. If you would like to explore the working code of this example, you can download it from the GitHub link. I have also provided a link where you can check if you qualify for a free community license to access all our Blazor products. If you found this video useful, hit the like button and subscribe to our channel. Thanks for watching.